Reinforcement learning with TensorFlow. Reinforcement learning (RL) is a type of machine learning paradigm where an agent learns to make decisions by interacting with an environment to maximize cumulative rewards. TensorFlow, being a powerful deep learning framework, provides tools and libraries for implementing RL algorithms and training agents to perform various tasks. Let's get into deep dive into RL with TensorFlow. So first, to understand the basics of reinforcement learning, what are the different aspects of it? First one is the agent, which is the learner or decision maker that interacts with the environment. The second, environment, is the external system or world with which the agent interacts. State, a representation of the current situation or configuration of the environment. Next is action, the decisions or choices made by the agent at each time step. Next is reward, the feedback signal from the environment indicating the goodness or desirability of the agent's actions. Next is policy, the strategy or rule used by the agent to select actions in different states. Next is value function, which estimates the expected cumulative reward of following a particular policy in a given state. The next thing that we learn is the algorithms, reinforcement learning algorithms. The first one is Q-learning, a model-free RL algorithm that learns action value functions, which are called Q values, through exploration and exploitation. Next one is Deep Q networks, which is DQN, an extensive of Q-learning that uses deep neural networks to approximate Q values for high-dimensional state spaces. Next, we have policy gradient methods, directly learn the policy function to maximize expected rewards by gradient ascent. Next is Actor-Critic Methods, which combines elements of both value-based and policy-based methods with separate networks for actor policy and critic value function. Next is Proximal Policy Optimizations, also called as PPO, a policy gradient algorithm that aims to find stable policy updates. These are different algorithms that we have. Next, we look at implementing reinforcement learning with TensorFlow. So the different steps are: first is define the environment. Implement the environment in which the agent will operate. This includes defining the state space, action space, reward function, and transition dynamics. Next is create the agent. Define the RL agent using TensorFlow. This involves designing the neural network architecture for the agent, including the policy network, value network, or any other required components. Next, we have to choose the RL algorithm. Select a suitable RL algorithm, whatever we saw above, based on the problem requirements and characteristics. TensorFlow provides implementation for various RL algorithms that we spoke about, such as like the DQN, PPO, SAC, which is also soft actor critic, etc. Next, we go into the training loop, where we implement the training loop where the agent interacts with the environment, collect experiences like state, action, reward tuples, and updates its parameters using backpropagation and optimization algorithms. The last step is evaluation, where you evaluate the trained agent's performance on unseen environment or test scenarios to assess its generalization and effectiveness. Next topic we look at is TensorFlow libraries for reinforcement learning. We have the TF agents, which is TensorFlow library for building and training RL agents, providing implementations of various RL algorithms, utilities, and environments. Next is OpenAI baselines, a set of high-quality implementations of RL algorithm developed by OpenAI, which can be used with TensorFlow. So there's a lot of different libraries coming out, but these are the top two that people are using right now. Next, we have applications of reinforcement learning. Where is it used? So first one is the game playing, where RL has achieved remarkable success in playing games like Go, chess, and video games. Next is robotics, where RL is used to train robots to perform complex tasks like manipulation, locomotion, and navigation. Next is everybody's favorite, autonomous vehicles, where RL techniques are applied in developing autonomous vehicles for decision making and control. We have recommendation systems. RL can be used to personalize recommendations and optimize user engagement. Last is finance, where RL algorithms are employed in algorithm trading, portfolio management, and risk assessment. So if you are into trading stocks, don't do it, just use these algorithms. It will probably be better than what you are thinking. So reinforcement learning with TensorFlow offers a powerful framework for training agents to solve complex decision making problems across various domains. By leveraging deep learning techniques and TensorFlow's extensive capabilities, developers can build and deploy RL systems for real world applications with ease. However, RL requires careful tuning of hyperparameters, it has exploration strategies and reward function to achieve optimal performance.